Hi, welcome to AgileTD After Work. Today we have Marc Mengler from Octomine there. So he's talking about from MCP to background agents and agent factories. So let's see what this is talking about. But first, we invite him to the front so that we can talk a little bit about him. Hi, Marc.
Hi, Jose. How are you?
I'm fine, thanks. And you?
Great, great.
Okay. Life is good?
Yeah, life is good. I'm calling from Karlsruhe, so behind me you see the start of the Black Forest in Germany.
That's very nice. I was there in October last year with my kids. Yeah, very nice. I can only tell the people if you have the time and the mood, so go there and enjoy. So, tell me a little bit about you. Who are you?
Yes. So I'm a data scientist turned entrepreneur turned machine learner turned entrepreneur. I've been in the machine learning field for now 11 years. Declined 2 PhD offers because my love has always been for creating AI startups, bringing both worlds together. And that's why I in 2016 started Understand AI. We scaled it to 65 employees and sold it for 8 digits.
Wow.
Then I went back to being a researcher once again. And with the research findings, we started Octomine, and we are now a team of 16 people, pan-European. And I'm spending 5 months every year in San Francisco.
Wow, not bad, my dear, not bad. Not everybody had that kind of career. So welcome. Like I said, now it's your time for the presentation. So enjoy. The people will be in the back. So if you need anything, I will just jump in. So and enjoy. Thanks so much.
Great. Basically, given my education, I'm often on the more theoretical side. Sometimes I miss academia. So I try to make this presentation a bit more practice-based, unlike my nature. And so a lot of the things like background agents and agent factors, because the field is very dynamic, I really wanted to focus on what's possible nowadays. These topics, agent factories, background agents, I will explain in the Outlook, but I will focus more on what's currently doable and achievable with MCP, A2A, and agentic workflows. So let's start with MCP. So it was initially released by Anthropic in November 24, but somehow, strangely enough, it didn't gain momentum until February 25. And that's normal for a protocol. Protocol are not the shiny things that everyone immediately grasps. And that's why we need to talk about it. The reason why I put February 25 there is because I was spending most of February and March in San Francisco, and a friend who's known me for 13 years was like, hey, Marc, you might be an AI researcher, but if you don't know about MCP, you're not really state of the art. So that feedback hit hard. And I went into the rabbit hole that is MCP in February. And a few weeks later, we released and open sourced our MCP client. And MCP is an open standard designed to unify applications. And that's the most important point, communicate context to the AI models. So context is the key, and it's also the main, so the C part of MCP is the main reason MCP was also invented. And it's a standardized protocol. Protocols are not very sexy, but there's a reason why MCP got such momentum, and I will explain. Because it's for connecting your existing AI systems to external data. Previously, this was often done via RAG and knowledge bases. But if you hear some cat sounds, that's my tomcat. He wants to go outside. It allows AI models to now, after several patches, safely access and use data from different data sources. And it's much more. Most people mistake it for just being a wrapper around the tools, tool usages, and APIs, but it can provide so much more. It can also provide resources and prompts. And maybe let's go back. LLMs, basically, they're incapable of doing anything meaningful. They are only good at predicting the next token. That's what they were trained for. That's their optimization goal. And if this fails, and it often does, because the knowledge base is outdated, depending on the cutoff date of the different models, you actually have to even manage for that cutoff date. And the easiest way to improve this and the answers of your agent is through the following three methods. Previously, the best one was called prompt engineering, and now everyone agrees that context engineering is the better word. And it helps to find a better activation of the attention mechanisms. Something that has been considered dead for many years, or every year, basically, people say it's the last year of retrieval augmented generation, so the second one. That's not true. It's both retrieval augmented generation and cache augmented generation are still very relevant. But you need to be somewhat technical and include them into your pipeline. For retrieval augmented generation, you also need a vector database. We will talk about vector databases in a bit. So it's not accessible to anyone, and it's also RAG is still somewhat an art. You need to find out how to complement the vector space, how to engineer the knowledge base. So that's not very accessible to everyone. And cache augmented generation, that's basically when you throw millions of tokens, so the content of multiple books, into the cache, and then you let the LLM decide which parts of those are relevant. But that's not always delivering the high results for reasons that we will talk about in a second. And then the last one, fine-tuning, that's very expensive. You often need ground truth data and supervised learning for that. And it can, most of the times, it's only accessible to foundational model providers. And you also run the risk of catastrophic forgetting. So why got MCP so popular? Because it's a good starting point that you can plug in for your context engineering and for improving the activation of your attention. But there are so many more best practices. You need to make sure you monitor the context. It's an entire selection process. What is relevant context, what is not? What context leads the AI astray and not? So it's basically its own field with monitoring and observability best practices. And I like the term context engineering more than prompt engineering, because it has become kind of its own discipline with established best practices. And previously, prompt engineering, that comes along with a lot of trial and error. And that's not part of engineering. And coming from the theoretical side to the practice side, most of you must have seen one of those answers by your AI assistant, by your LLM. I don't have access to these files. Please install the Playwright package. I don't know how to execute that action. I don't have access to the database. And MCP helps solve these practical problems, and is a common language between your data systems and your AI. And so why does context matter? There's a famous paper from a few years ago, Attention is All You Need. And I thought about calling this slide Context is All You Need. But context is important to break down the data silos, especially in enterprises. You don't know what your teammates and your other departments know. And you can often, similar to RAG, enhance the knowledge of the LLM with proprietary data. And since you don't know what the LLM knows, you have to find a better initialization of where in the vector space the right answer might linger. And context, the right context, if it's concise, can be key to finding that vector space that provides the right answers. But there are phenomena that I will go. So the first one is called context rot. And I will also go into a Stanford research group on developer productivity. And they designed different studies with up to 600,000 developers. So this is somewhat meaningful. Yes. So context rot. The study is by Chroma. Chroma is a vector database provider. Vector databases is what you use in retrieval augmented generation. And it helps connecting non-proprietary data, especially sensitive data, into and incorporating them into your LLM answers. And here you can see different graphs. We will not go into detail. If you have questions later on, we can go into more details. But basically, you see accuracy on the y-axis, and it starts with 100% accuracy, and then with increasing input length, so context tokens, the performance deteriorates a bit after a certain tipping point. And in blue, you can see the lexical matching, which means the same keywords are being used to describe the same phenomena. But in the semantic matching case, you use different keywords that are semantically similar. Like you would, instead of saying this was a hawk that attacked the cat, you can say it was a boar, or use different words for the same thing, which are semantically identical or very similar. And in the case of semantic matching, so the red graph, you can see that with increasing input context length, the performance even degrades significantly more than when you have when you always use the same keywords. And so why is this important? I mean, we are a testing and engineering meetup. And for example, imagine you have Python, where there's, according to the Zen of Python, one and only one preferred way of how to implement things using the same keywords. That would be somewhat closer to the lexical matching case. But on the other side, if you use Scala, you usually have many ways of expressing the same thing in a functional way, in a declarative way. There you will see higher degradation with more context of the, and also a similar result was found when you use the cosine similarity between the words. If you use highly similar words, then it doesn't degrade as much as with higher cosine, with lower cosine similarity. So this means that performance decreases with ambiguity. And similarly, also in the realm of programming languages, it would decrease with using inconsistent ways of describing the very same thing. And not only that, these ambiguous terms can also be seen as kind of a distractor. So if you have a large code base with which grew over time, and you started maybe with in React with a class-based approach, and then went over to a more functional way of writing React code, and maybe you also had different ways of how to manage the state via React hooks, or different things which were in fashion and out of fashion. So these could be seen as a distractor, and the more of these distractors you have in your context length, which could be like the entire code base, the sooner the performance will degrade. So these are some of the findings from the Chroma study. There's also a study from UCLA, Tencent, AI Seattle, and UC San Diego. And it also finds that with in the blue chart, with more messages consistently across all the different models, the performance degrades. And long mem eval is a accepted benchmark, and it's still meaningful. And then we go into the Stanford studies. They had multiple studies on different topics, but it's a lot of it is very significant because they included up to 600,000 developers, and not only open source, but also 80% were private repositories on GitHub. So it's like company and enterprise code bases not just open source databases. And yeah, also they find that basically with increasing code base, your AI performance productivity gain decreases significantly. And they also give some recommendations by improving the context and models. This could change over time and in the future. And yeah, we will go into some of those recommendations and also what we found from our own productivity gains when using Cursor, Windsurf, etc. But yeah, this first study is basically yeah, the more lines of code, the higher the context, the lower the productivity gain from AI. And so why is that? They digged deeper into these findings. Yeah, for example, here the sample size is a bit lower. And I have to highlight that it's from August 24. So that's almost a year ago. And back then, the AI cursor, etc., were not as good. But still, AI makes it easy to generate and understand code. So a lot of new code was churned out. But also a lot of it needed to be refined and bug fixed. So you need to basically deduct this rework. And so the net productivity gain from AI was 15 to 20%. And it really depends on which design domain you use it in, which code base you use it in. I will show more of those dimensions, but we also see a 10 to 15% increase on our code base from using Cursor, Windsurf, etc. And the interesting thing is that there are stark differences between the productivity gains on a greenfield project where you don't have a lot of lines of code already written, if at all, or a brownfield code base, which has grown over years or decades and included many different programming styles. So yeah, you can basically see that for low complexity greenfield tasks, the AI productivity gain was higher than in other settings. And also especially higher than in brownfield settings for low complexity tasks, like boilerplate code, writing unit tests. But for high complexity tasks, it was much lower in terms of productivity gains. And sometimes the use of AI in high complex tasks on brownfield code bases was even deteriorating and net negative in terms of productivity gain. And so they, yeah, a lot of consultants do, they came up with a 2x2 matrix in terms of task complexity and code base maturity. And yeah, they found that basically there are different productivity gains in all these four settings. And you need to take all of these dimensions into consideration when deciding what to use your AI support on. And yeah, another really important dimension is also the language popularity. So when in 2022, after I left my previous company, I was writing a lot of Tauri.js code. And at the time, 22, GitHub Copilot was really not a big boost for this very new JavaScript framework. So yeah, even in lower complexity tasks, it would hardly give me any speed up. And that's why I had to switch to a high popularity framework, Electron.js. And there I saw, yeah, also more productivity gains, not in those ranges because it was 2022, but still maybe 5 to 10% at the time. And this will lead to AI basically dictating the stack. And the more I know for certain that Python is the main language that they optimize for. So Python and the most important, most popular JavaScript frameworks, and maybe in the enterprise setting, Java, will become more ubiquitous through AI performance, giving you more gains on these high popularity frameworks and languages. So AI will also basically dictate your tech stack and your languages. And yeah, they basically found that all of these 5 dimensions need to be put into consideration. Yeah, the most critical of it all is context length, as has been shown by the Chroma study and the long mem eval benchmark as well. And yeah, when we designed our MCP client and server, we also thought that, hey, let's open source our MCP client and server and make it available in Octomind, give it as much context as possible, give it as many guardrails as possible, and it will have a high productivity gain from those. But actually, what we found is that, and this is an inside view into both our documentation and yeah, our architecture decision records. We have a monorepo, and the ADRs, the architecture design decision records, live in this monorepo, and we for other reasons we had to basically open source and put our docs in a different code base because Mintlify needed read and write access to our repository, but we found a different way of integrating our docs and knowledge base, and we have best practices like formatting. Everything is written in TypeScript, so we also have type safety end to end. We have invested heavily into linting, first with ESLint, now with Biome, and you can imagine we are a testing company, so we write a lot of tests. We have many units, and also, since we are an end-to-end testing company, many end-to-end tests, and we use them and execute them. And of course, we also have cursor rules. We blacklist certain commands. So one recommendation, one thing we found out was that for front-end components, for example, so for different tasks, you need different contexts, because you cannot just throw all of it into into context. Even if Gemini has 1 million tokens context size, which is as much as 4 really big books with 400 pages each. That's not to say that it will help. Quite the opposite. It will deteriorate your performance, as the previous studies have shown. And for example, for writing front-end components, you would use a specialized framework like V0 from Vercel. You would give it the docs into the context because it's user-facing, and you would give it the product decision records, but not the architecture decision records, because they are more backend focused. And of course, you should give it the end-to-end tests and the results of the test execution. And with that, you should be good to go for productivity gains with your cursor windsurf when it comes to front-end components. But for back-end components, you, of course, need to give different contexts. You need to give those ADRs, which basically describe why we did certain API architecture decisions, why we have certain CI processes running, etc. But these back-end heavy components, or you would use a different backbone, often Claude Sonnet 3.7 or Gemini Pro 2.5, but you would also use your cursor rules and blacklist certain commands because it's very critical. If you have like sensitive flows, payment flows, you might not even want to use your AI a lot. And what we've also seen is that MCP has seen a lot of adoption from thought leaders, big tech startups, and established players. Currently, today is the second day of the Microsoft MCP Dev Days. Their entire series on MCP published by IBM, and Amazon AWS also agrees that MCP is the way to go, which is somewhat surprising, but this is what a protocol needs. It's adoption by all these big players, thought leaders, and fast-moving tech companies. And most of these already have an MCP server, client or server that you can just plug in, connect to your MCP hosts, which are often Windsurf, Cursor, Claude Desktop. And the magic of MCP is not using like one client, one server. You've seen many of those demos, but stacking them together, chaining them, is really what is moving the needle, and not just using one of them. And internally, we are also working on stuff like the connecting a Figma MCP to find inconsistencies between our Figma designs and the actual UI of the app. So the more of these MCP components you can chain together, sometimes the better, if it's the right components and if you give them the right context. And but MCP is so much more. What 90%, over 90% of the MCP users do is they use MCPs to wrap tool calls. And that's easily done because you can basically plug in your existing APIs, wrap them around, and there are different service providers for that, and you can turn them into an MCP. But MCP is so much more. You can also give like a list of data that can be read. So, for example, having access to your to the files on your EC2 instance or S3 bucket. You can also have pre-written templates that, similar to autocomplete in the Google search, can help the users accomplish the tasks and basically autocomplete the prompt. Yeah, roots and sampling is less often used, but the main three ones is really tools. So 90% only use tools, and prompts and resources are also very undervalued, but also very helpful and could be an ace in the sleeve of MCP. Yeah, regarding the time, I'm not going to go into details, but you can read those details on MCP tools, what they encompass, what the MCP resources encompass, and in detail with the MCP specifications. But the important thing to know is that hardly anyone uses this functionality, and most of the users just use tools and not the prompts or resources. And that's also kind of the problems and challenges with MCP. It's usually a wrapper around the existing tools. And we only saw 1 out of 28 companies use sampling or roots in a small sample size, and 8 out of 28 companies use the resources. So there's a lot of hidden potential. And I think this is also why MCP will win, because there is this well-known and sometimes less known and less accepted paradigm called worse is better. I recently wrote about it on LinkedIn and Twitter. And it's quite interesting because there's the Ruby on Rails creator, David Heinemeier Hansen, said, whenever I ship the first version of a new product, I leave something a little broken. Nothing sparks collaboration from developers faster than imperfection these people know how to fix. And it's even a well-established programming paradigm. And it's also the reason why imperfect protocols like TCP/IP won against the much more polished, much more advanced OSI stack. And it's also why REST won against SOAP, which is especially the enterprise counterpart. And as I mentioned previously, the community adoption being loved by developers and a quick turnaround of their ideas, their feedback into specification or implementation is key. And MCP did exactly that. And so in May, they patched some of the shortcomings like authentication, authorization. That was a huge security issue. Streamable HTTP and backwards compatibility, and thereby they showed that they really know about the shortcomings. They potentially even, because they were AI researchers, it was born by AI researchers at Anthropic, but they implemented those shortcomings really quickly, listened to the community, and now we have a similar authentication. It's the that we have an agent-to-agent protocol, and it's the OAuth 2.1 flow. And yeah, we don't need to go into details, but basically authentication authorization is now better implemented in the new MCP specs. And the same with a streamable HTTP transport. And yeah, it's I think also a reason why MCP are in the pole position to win the protocol wars. It's the swift integration that we just discussed of the community contributions, high adoption, big and small players, thought leaders, and not MCP's full potential is not really used. We still have the resources and prompts that are underutilized. And going back more into theory, so why I think MCP is in the pole position are especially these three advantages. Pluggability, so you can use just existing APIs, turn them, there are service providers who do that, turn them into an MCP. Yeah, so it's easy to use. We even, if you don't want to integrate it into your cursor and implement the MCP.json, etc., the easiest way to use an MCP server is in the Octomine tooling under app.octomine.dev, and the MCP server has full context of our knowledge base, so you can ask it questions, and it can even execute tasks. So it's a full-blown general purpose MCP agent included in our tooling. And I think more companies will follow suit and integrate their MCP's servers into their tool, because it's basically like you already have a colleague who's onboarded and who can execute tasks in the tool. That's especially handy if you're a new user. And I think, this will become an industry best practice. And we've seen those post hoc and other thought leaders include these general purpose MCP agents into their tooling. So you can just plug it in and start using it. And discoverability. So the agent that I just shown you, you can basically ask it to create a new test case for me, so it can execute. It's aware of what it knows, what it can do, and what it cannot do. So that's very handy. And it basically is a wrapper around your tool chain and simplifies using those tools. I could have used that when I inherited a tool chain from my parents. I did not know what to do with most of those tools, and an MCP server would have known how to use and what to use each of those tools like Hammer, etc. for. And composability, we spoke about this a bit earlier, that you can basically stack MCP components like Lego pieces. And this is also the main property that allows MCP to be the gateway for agentic workflows. And soon, even in the enterprise. I think a lot of big enterprises already use it, and more will follow. And so let's talk about A2A. It's similar but different to MCP. It's the Google proposal for direct agent-to-agent communication and connecting agents. And similar to how RESTful APIs and GraphQL are used, they are both competing, but also complementary in a way. And here you have different different agents that communicate with each other, that can also execute tasks and give feedback on the state of and completion of the task at hand. And I will not go into too much detail, but the big value proposition are the agent cards. And this is what makes it very complementary to MCP. But you can also use it in combination with MCP. MCP is basically just an abstraction over the tools, while agent-to-agent sits on a different and can sit on a different layer, communication layer. In agent-to-agent, you can have the different tasks, but given the vast adoption and the momentum of MCP, I don't think A2A will replace, but be used complementary to MCP, and the agent card is the main reason for this. Agent card, so basically it's just like you had those Panini cards of the different soccer players with strength and weaknesses. You can have an agent card which has a name, a description, but most importantly, the capabilities and skills array. So it has a skill array from 1 to n, and it's hosted under the URL and then agent.json. But it's also somewhat problematic because the agents can overstate their capabilities and their skills, and it could potentially be used as a honeypot to gain access to more context from other agents. So I think this trust issue needs to be addressed before agent cards and A2A will have a vast adoption, similar to the one with MCP. MCP is also not perfect. It has shortcomings, but that's by design because it was created by AI researchers, not engineers. I think that I will skip those slides for the example task, but basically it's just a JSON specification with a consistent ID, so it's idempotent, and to make sure that the agent request and the response from a different agent is considering the very same task at hand. And also for the push notification request and response, the ID is the same if it's concerning the same push notification. And this allows it to not have like an open stream, but it can be asynchronous. And I think what the future will show is that MCP and A2A are already used and can be used, especially in a complementary setting. MCP is too strong when it comes to the different tool use, and it's too widely adopted. So it will live very likely alongside A2A and be a layer downstream of A2A, similar to how RESTful APIs and GraphQL APIs coexist. Coming to the last part, the outlook. It's a very dynamic field. Every day you have new players, new registries join. I'm in contact with the UTCP creators, which is kind of a domain naming service for agents. And time will tell if they will be the go-to solution for DNS in agentic workflows. And I think a combination of MCP, A2A, improved with band-aids, with patches, and potentially UTCP, depending on its traction, will enable the transition from what we currently have, agents, specific agents using their specific tool chain, and transition into enable background agents and ultimately agent factories. Cursor just 2 weeks ago released a background agent called Bugbot, which lives in PRs. And it's an asynchronous bug finder. And from a theoretical standpoint, you would want to have different agents from different suppliers with disjoint vector space, with disjoint training data that they were trained on, to generate and discriminate each other's ideas. And an agent factory can look similar to what Clark is doing. Clark is basically a lovable for enterprise applications. And there you have a prompt. So build an app for our operations team to manage grocery deliveries, pull orders from Snowflake, driver locations from the API, and payments from Stripe. And this is the planning part of the agent factory. And it will then communicate its reasoning and its plan to a design agent that could be a Figma, MCP, or A2A agent card, an IT admin agent, and an engineering agent. There are multiple contestants for that. And it's also important that you have different agents from different suppliers, because they were all trained on different data and with different optimization goals. And in the background, so a lot of this can happen in real time, as already Cursor and Windsurf are proving that their engineer agent works well in real time. But other agents will be more in the background, like the security agent, which basically pen tests the generated application and gives back its feedback to both the designer agent, but also the engineering agent. And for my company, for Octomind, what we are building is the QA agent, which will also be in the background and be in contact, exchange with these other background agents and real-time agents to deliver an app that is within the specifications and if you zoom out a bit more regarding engineering, Sam Altman said when he was asked what's the future of software engineering, the future of software engineering is StarCraft. And software engineering also includes testing and QA. And so it will look a lot like the StarCraft interface on the right. So you can zoom in to what your workers are doing. Okay, they are mining minerals, and there are still so many minerals left. But you can also zoom out, go to the minimap, and look at different areas of the map, what your other agents are doing. And you can zoom in and check what they are doing and oversee how the process in the factory is catching steam or isn't catching steam. But you need to be careful. Don't give them the full context. We talked about context selection earlier. All of the really good tools have an explicit or implicit autonomy slider. Basically, in some tasks of the engineering process, you want more autonomy, like documentation generation, unit testing, front-end components. But with more back-end critical security-related engineering tasks, you want less or almost no autonomy and full human control. And so all of these different agents, depending on what they're currently working on, they will also give more insight into their processes. They will zoom in and give the human the control. I think that's the future of engineering and testing. It's very dynamic, but I think in 5 years, engineering will look different from what it does today. So these are my 2 cents. Thank you for your attention. And now let's go to a short.
Yeah. Thanks so much. It was an amazing talk. I learned a lot. So from your last sentences, when you say, I mean, when you have this factory of agents, so I have my doubts. Okay, so that I mean, when we are talking about complex projects or a complex application, that's not that easy. So you may need to start step by step. So you will not have a big bang, right?
Yes.
So step by step, looking.
Yeah,
because
yeah.
I think that it makes sense from my point of view. I mean, if the part that you are using AI to develop things, if this part is small enough that the quality that is coming is the right one you need, because it's like you said in from this other study, when you say that complex, when the things that you develop is complex, sometimes AI is going to be worse than better. So I think one of the point will be, I mean, it's the whole story of the software engineering, that you need to break the complexity. As soon as you break the complexity, then it will be easy to develop things. Is this your opinion, or I'm crazy?
Yes, that's Professor Tenenbaum once said software engineering is really about turning the problem into multiple less complex sub-problems. And we've also seen in when using AI agents, if you describe it sequentially and have a very precise formulation of what is the task at hand, and then you step by step sequentially go and work on these tasks, either as a human or AI assistant or just agent based, then it delivers better performance. And yeah, there will be more critical settings like back-end tasks, payment logic, etc., where you might not want an AI at all. And on the front-end side, front-end components that are not security relevant. You want more autonomy for the AI and zoom into what the and maybe only have like a macro view of what the AI is doing there, but still be able to take over. But yeah, on the back end side, I think especially on a brownfield project with a large history of different coding styles and where even humans don't understand what specific parts are doing. If you can turn them into smaller atomic chunks, then it makes it simpler. But you might not have the compliance of AI being used for that. You will have a blacklist of commands and areas of your code where the AI will not be allowed, for sure.
Okay. So thanks so much. It was, like I said, a very interesting topic. I'm looking forward to seeing you at the Agile testing days. I will will pass your booth by, and I will have a look into your application and the things that you have done, because it's very interesting. And as you said, many things are moving, and they are moving quite quick. And I guess that even what you're offering today is going to be a little bit different in 3 or 4 months ahead. Okay. Thanks so much. There's no question in this case. Thanks so much for being there. It was an amazing talk, and I can only say it again. Okay. Thanks so much. Enjoy.
Enjoy. Take care. Bye-bye.
Bye-bye.